Hello students, and welcome back to another geometry video. You know what to do. Pause the video, answer these problems in your notes, and then unpause, and we'll talk about them together. So, the first question asks, what does the word transform mean? In a non-math context, what does the word transform mean? What does it mean to transform a picture? What does it mean when a tadpole transforms into a frog? What does it mean to transform? Well, simply, to transform something means to change it, but to change it in a special way. Tadpoles turn into frogs in a very special way. When we talk about transformations in math, we're also talking about changing things in a special way. And that's all that's what chapter 4 is all about. So, changing things in a special way. What would it look like to transform a graph? Maybe you've seen some of this before, maybe you haven't. But if we were to transform a graph, it depends on what the graph looks like, right? We can transform the line, y equals x. We can make it steeper, so we can change it to make it steeper. We can change it to make it less steep. So lines, maybe you've seen transformations of lines before, but what happens if we have a shape? A shape in the coordinate plane, and we want to transform this shape. Well, that is what chapter 4 is all about. So, without further ado, let's jump in to chapter 4. The first section of chapter 4 is all about translations. So our learning target is that you know what a translation is, and your success criteria is that you can perform translations and write rules for translations in the coordinate plane. So perform translations and write rules for translations. Now, I know what you're thinking. Great, translations, but what is a translation? Well, have you ever heard of the cha-cha slide? The slide to the left, slide to the right, crisscross, the cha-cha slide. So, when the cha-cha slide says slide to the left, that's what a translation is. Anytime you see the word translation, I want you to hear the cha-cha slide in your head. Slide to the left, slide to the right. A translation is a slide. It's we take the shape, we take a shape, and we slide it to the left or the right, or we slide it up and down. So, a translation is a transformation. That's why we talked about the word transform in our entry task. A transformation that moves every point of a figure the same distance in the same direction. So every point, A, B, and C, all get moved in the exact same way, in a special way, just like we talked about in the entry task. So in this example, we moved the blue triangle 1, 2, 3, 4 to the left and up 1. We also moved the point B. We moved it 1, 2, 3, 4 to the left and up 1. And we moved the point C 4 to the left and up 1. So every point in the figure gets moved the same distance in the same direction. Now, you'll see some other words on the screen here. Pre-image and image. What are these about? Now, these words are actually very important, and we're going to keep using these words all throughout chapter 4. So, pre-image. What do you think of when you hear the word pre? Pre-test, post-test. Pre means before. So the pre-image is the image before you move it. The pre-image is the image we start with. The image we start with, the picture we start with, the shape. Image just means the shape, the picture. So the pre-image is the image we start with. Notice how the pre-image, the points that make up the corners of triangle ABC, the points are just A, B, C. Now, notice the points of the image. So we have pre-image and we have image. The image is after we transform the figure. After we transform the figure. Now the image has points A with a little apostrophe, B with an apostrophe, and C with an apostrophe. What are these apostrophes here for? Well, the way that we read this A prime. We don't say A apostrophe, we say A prime. And what the prime tells us is that that point belongs to the image. The pre-image has normal points and the image has A prime. So we know that it is point A but moved. It's point A after the transformation. So that's what the primes are. Okay, so that's the gist of translations. Now let's dig a little bit deeper into translations. So, a translation moves every point of a figure the same distance in the same direction. We just talked about that. More specifically, a translation maps. Now, maps, that seems a little bit weird, but I want to show you this language because it continues in math. You're going to hear it in geometry, you're going to hear about it in advanced algebra, you'll hear about it in pre-calculus, you'll hear about it all the way up on to linear algebra, ring theory. This language about mapping in mathematics doesn't go away. So I want you to be familiar with the language in case you want to take more math classes. So a translation maps or moves, but moves in a special way, right? A map tells you where to go. So when we have a map in math class, it's where it tells you how the shape is supposed to move. So a translation maps the points P and Q of a plane figure along a vector to the points P prime and Q prime. So if this segment PQ is the segment we're starting with, points P and Q, or the end points, move along a vector. Now a vector is just a line that points in a specific direction. That's all a vector is. We write vectors in this way. You'll see more about that in our first example. But they are moved in the same direction, the exact same amount. So this is a detailed picture of what a translation looks like. Okay, let's move on to our first example for today. Translating a figure using a vector. Now, when you see this vector with these pointy brackets like this, the first number has to do with x, the second number has to do with y. Just like our coordinate points have x first, y first, vectors also have x first and y first. But what this vector tells us is that because it deals with x, we have positive 5 for x. And what that means is that we're going to slide our triangle 5 units to the right because the x-axis goes left and right. If I'm going positive, I'm going to the right, and if I'm going negative, I'm going to the left. So because this is a positive 5, we are going right 5. And because the second number deals with y, the y-axis goes up and down. So because this is a negative number, I'll be going down 1 unit. So let's go ahead and read the entire question. The vertices of triangle ABC are: A is at 0, 3, B is at 2, 4, and C is at 1, 0. Translate or slide triangle ABC using this vector. And when it says using this vector, it means right 5, down 1. So let's go ahead and draw triangle ABC on our graph over here. So 0, 3, I'm going 0 to the left and right, and then up 3. So this is A. And B is at 2, 4, so over 2, up 4. And C is at 1, 0. Okay. Perfect. So there is triangle ABC. Now, I'm going to switch colors because remember, we had, when we looked at our definitions, the pre-image was blue and the image was red, so I'm going to keep using those colors. So if I'm moving right 5 and down 1, I'm going to do that to each point. So let's take A and let's move it to the right 5. 1, 2, 3, 4, 5, and down 1. So here is our new point A, and we call it A prime. A prime is like new A. Okay, we're going to do the same thing with point B. 1, 2, 3, 4, 5, and down 1. And point C. 1, 2, 3, 4, 5, and down 1. Make sure you label all of those points with B prime, C prime. And we will connect the dots. And there you have it. We translated triangle ABC. We slid it 5 units to the right, 1 unit down. So we are finished. And we can check and make sure that we were correct. Yes, indeed. That's what our picture looked like. Exactly what our picture looked like. Awesome. Okay, let's move on to the next part of our lesson today. A rigid motion. You're going to hear more about this as we move on through chapter 4. A rigid motion is a transformation that preserves length and angle measure. What does it mean to preserve something? If I am preserving it, I am keeping it. I'm keeping it safe. I'm keeping it the exact same. If I want to preserve this family heirloom, I am keeping it in the shape that it is when I got it. So, I am preserving length and angle measure. I am not changing length and angle measure. Notice, in the picture I am covering up right now, between DEF and D prime, E prime, F prime, notice how the sides of the triangle are exactly the same. DE is the same as D prime, E prime. DF is the same as D prime, F prime. And all of the angles are the same. Any rigid transformation keeps the sides and the angles of the shape exactly the same. So the shape and its transformation are congruent. Okay. Another name for a rigid motion is an isometry. That's another word that you'll hear if you keep going on in math. Isometric. Wonderful word. Okay, so a translation is a rigid motion because When you translate a shape, you're not changing it. The sides stay exactly the same, the angles stay exactly the same. You're not changing the shape. So that's what it means to be a rigid motion. Okay, all right, so let's move on to our next example, writing a translation rule. So now, in the first example we did, they gave us 5, -1, and we said, we're going to go right 5 and down 1. Now, they gave us the picture, and they want us to write the rule. So now we're doing the opposite of what we did in the first example. So, let me get a different color, and let's look. Let's look at A prime and A. If I move from A, remember, A is the original. The blue one, or A without the prime, is the original. So we're going to go from A to A prime, from B to B prime, and from C to C prime. So if I start at A and I want to get to A prime, I have to go left 1, 2, 3, 4. So if I'm going left 4, I'm going -4, because left in the x direction is negative. And I'm going up 1. Up 1 is +1, because going up on the y-axis is the positive direction. Okay, let's make sure that it's the same for B and for C. 1, 2, 3, 4, and up 1. And for C, it is 1, 2, 3, 4, and up 1. So yeah, this rule works for every point, A, B, and C. So it is the rule for our translation. Now there's another way we can write this. We don't have to write it in, this is called vector notation, because we wrote it, that what these triangle brackets mean is that we're talking about a vector. So this is vector notation. We can write it in a different way too. We can write it x, y to x minus 4, y plus 1. We can also write it this way. Now, on your homework, on a test, it will say, write it in vector notation or write the rule for the translation. They'll tell you which one they want on a homework or test, but I want you to be able to see both of these notations. Okay, let's check and make sure that we were right. Moving along the vector -4, +1, 4 units left, 1 unit up, x minus 4, y plus 1. Awesome. We did the exact same thing. Yay. Okay, let's move on to our next example, translating a figure in the coordinate plane. So now, we're doing the same thing that we did in our first example, but now it's not in vector notation. So, I'm going to graph my pre-image in blue, A, B, C, D. So A is -1, +2. B is -1, +5. C is 4, 6. And D is 4, 2. Connect the dots. Beautiful. So we have a trapezoid here. Now, I'm going to get red because I'm going to graph the image. After the translation, x plus 3, y minus 1. Plus 3 would mean that I'm moving in the positive direction. So this is moving right 3. Now if I have y minus 1, that means I'm moving in the negative direction along the y-axis. So this is down 1. Okay, So let's do just that. We'll start with point A, and we'll move right 3 and down 1. And we're going to call that A prime, because it's the image of A. Same with B, 1, 2, 3, and down. B prime, 1, 2, 3, and down. C prime, and 1, 2, 3, and down. D prime. And now we'll connect the dots. A good way to check and see if you're correct on problems like these is, do the shapes look exactly the same? Does A, B, C, D look exactly the same as A prime, B prime, C prime, D prime? Well, in our case, yes. The shapes do look exactly the same. It just looks like the red one was moved right 3, down 1. So, awesome. Awesome. Let's check and make sure we were right. That looks exactly like what we did. Now, this is something we didn't do. So, you can say write 3 down 1, and you can count the boxes just like we just did. Another way that you can do these problems is you can calculate the coordinates based on the rule. So I can take my original points, A, B, C, and D, and I can add the x-coordinate plus 3, the y-coordinate minus 1. -1 plus 3 gives me 2. And 2 minus 1 gives me 1. Now, I didn't show you how to do it this way because I don't mind which way you do it. I don't mind if you count the boxes. I don't mind if you show your work like this. Calculating the coordinates is a great way to check your work and make sure that you're correct, but I'm not going to require it. I want you to do the way that makes the most sense for you. We are going to continue to write rules or maps, because you'll see A moves to A prime, B moves to B prime. So we're going to continue to write maps like this in 4.1, 4.3, and beyond. But for now, I don't mind which way you do it. Just get the hang of transformations right now. Okay, awesome. Now, the last thing we're going to do today is a composition of transformations. Now, a composition means multiple things together, right? Putting things together. So when we have a composition of transformations, we're going to be doing multiple transformations together. Now, a very interesting thing about compositions of transformations is that they are also rigid motions. And in fact, the composition of any 2 or more rigid motions is a rigid motion. We're going to learn about more rigid motions in 4.2 and 4.3. But you can put as many rigid transformations as you want together, and the final transformation that you get will also be a rigid transformation or a rigid motion. So I thought that was really interesting. Okay, let's move on to our very last example for today, performing a composition. So let me get blue because our pre-image is blue. Graph segment RS with endpoints -8, 5 is R, and S is -6, 8. And its image after the composition. Okay, so remember, a composition is multiple things together. So I'm going to do both of these translations and put them together. I'm going to do each one separately so that we can keep track of them. So we're starting with our, let me color code this. This is our pre-image. we're starting with r, negative 8, 5, and s, negative 6, 8. We're starting with these. Then we are moving to the image using the first translation they gave us. So x plus 5, y minus 2. Now, if I take negative 8 and add 5, I get negative 3. And if I take 5 and subtract 2, I get 3. And that's how we can get the coordinates of r prime. So, I take my x coordinate and add 5. I take my y coordinate and subtract 2. Just like the rule tells me to. That's why it's called a rule, is it tells me how to get from the pre-image to the image. Okay. And let's do the same thing with s. Negative 6 plus 5 gives us s prime. Negative 6 plus 5 is negative 1. And 8 minus 2 is 6. Okay, now let's graph r prime and s prime. Negative 3 plus 3, r prime, and s is negative 1, 6. S prime is negative 1, 6. Now we can check and make sure that we did this translation correctly by counting. 1, 2, 3, 4, 5. Beautiful. And down 2. Perfect. R, 1, 2, 3, 4, 5. And down 2. Perfect. Okay. Awesome. Now that's our first translation. Done. What about our second translation? So now we're going from r prime and s prime. Now we're going to a different shape. And I'm going to do this one in green. We're going to a different shape using another translation. X minus 4, y minus 2. So we already know that this should be left 4, down 2. We know that. And we could just count the boxes and get there. But let's practice using our other method. So negative 3 minus 4. X minus 4. Negative 3 minus 4 is negative 7. And you know what? We won't call this r prime. We already have an r prime. Instead, we'll call this r double prime because it's the image of the image. So we'll use 2 apostrophes or 2 primes. Okay, and now we'll take 3, the y coordinate, minus 2. 3 minus 2 is 1. Awesome. We'll do the same thing for s prime, excuse me, and we will find s double prime. So, negative 1 minus 4 is negative 5, and 6 minus 2 is 4. So let's graph r double prime and s double prime. Negative 7, 1, r double prime, and negative 5, 4 is s double prime. Now, does r prime s prime, does that look exactly the same as r prime s prime? Yes. Yes, it does. And we can check. Remember, we can check. Did we go left 4 and down 2? Yes, we did. And left 4 and down 2. Yes. Yes, we did. Perfect. Let's check and make sure that we were correct. Okay, we went 5 units right, 2 units down, and 4 units left, and 2 units down. And look at that. They also had S prime, S double prime, and they color-coded just like me. If you want a color code like this when you do your homework, I highly recommend it. Color coding helps us keep pictures separate sometimes, and math is very visual, whether you think it or not. Okay, that is our last example for today. If you have questions, please, 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 please ask those questions. Get them answered. Remember, questions mean that your brain is growing. Confusion means that your brain is growing. So if you have questions, it's a good thing. And please get those questions answered. All right. If you would like to practice the skills you learned in this video, here are some problems that you can do to practice those skills. Remember that these might be different than the homework that your teacher has assigned, so do the homework your teacher assigned, but you can do these as well if you'd like. And as usual, we're going to end our video with a launch. Today's launch comes from Rosa Parks, and she says, each person must live their life as a model for others. Each person must live their life as a model for others. Are you living your life as a model for others? What does it mean to be a model for others? Well, when you think of a role model, it's someone that you want to be like. Are you living your life in a way that other people want to live like you? If you're not, is there a reason why? And if you are, awesome, awesome. If everybody lived their life as a model for others, well, I want to be kind to other people, and I want people to be kind to other people. I want people to be respectful of others, so I'm going to be respectful of others. If everybody lived their life as a model for others, the world would be a much, much better place. So, that's my launch for you today. That's my challenge for you today. Live your life as a model for others. Okay, that's the launch for today. Take it with you as you go throughout your day. Have a wonderful rest of your day, and thanks for being here. Thanks for watching. Bye.